All right, so for question 1, when we're setting up our star, there are 8 different vertices that make it up. 4 in the center square, so 0, 1, 2, 3, and 4 vertices making up the triangles, 4, 5, 6, and 7. And then going down to the indices, there are 6 triangles making up the star. Using counterclockwise rotation, the indices are set up as 0, 1, 2, 2, 3, 0 in the center square. And for the 4 triangles, we have 0, 4, 1, 1, 5, 2, 2, 6, 3, 3, 7, 0. Going over to question 2, if we load this up, number of vertices is declared to 4 right now, so that will pull up a square right here. And then if we close out and change that to something else, let's try 7. And then this pulls up a 7-sided shape with 5 triangles making that up. So the vertex buffer, the first vertex is always at 0.500. So that's right here. And then for the other vertices, we use cosine and sine to get the new x and y values to move, to get that new position. So the values in here, we have 2 pi over the number of vertices. We multiply that by I for each new position. And then we multiply that by 0.5. So this is the value for the cosine and sine is 2 pi over 7 right here. This would be 4 pi over 7, 6 pi over 7, and so on. And then the indices, this code right here is setting up a pattern. So we have 0, 1, 2, 0, 2, 3, 0, 3, 4, and so on. Basically, we have the last value. We take it over to the next row, make it the second value, increment it by 1, and keep doing that depending on how many indices we have. And then just quickly taking a look at our other questions. We have the triangle with 2 of the vertices are at 2 for the z range. The NDC z range only goes from 0 to 1. So if we put in the z value for anything beyond that, it won't render properly. It'll seem like it's not visible. So that's why these 2 vertices do not show up on the screen. And then taking a look at the viewport, the left X and left Y, we use that to move the camera around and show different parts of the window. The reason we might want to do that is say that you have a bunch of different objects displayed on the screen, but they're not all positioned correctly the way you might like. So instead of moving the objects around to get them all within the viewport, we can just simply change these values to move the camera around instead and get a better angle of what we would like to see. And then finally looking at the DXGI formats. In this part of the code, we are setting up our settings for the display, what we want to display on the window, so the width, the height, the format in this particular line. So right here we have 32 bits assigned to red, green, blue, and alpha to set up the combinations for the colors and the transparency of the window. And we also have unorm. This stands for unsigned norm, which goes from 0 to 1. So this particular part is the depth buffer. If this were S norm, that would mean signed norm, which would contain both positive and negative values. And then we also have this R16 line. At this point in the code, we have set up our index buffer. And right here, we are telling the assembler to hold on to the index buffer for future use. This is assigning 16 bits to red in an unsigned int.